Have you ever wondered what happens when a swarm of tiny, buzzing drones heads towards a multi-million-dollar tank? It's like a scene from a science fiction movie, but it's the reality of modern warfare. And in this new era, Russia is scrambling to develop defenses against this ever-present threat. Today, we're diving deep into the fascinating and rapidly evolving world of Russian anti-drone technology. From microwave cannons to robotic machine guns, we'll explore how they're trying to counter the drone revolution. This isn't just about military hardware, it's a story of innovation, adaptation, and a high-stakes technological arms race that's redefining the battlefield. So, stick around as we uncover the secrets behind Russia's new drone shield. First, let's set the stage. The widespread use of small, commercial-style FPV drones has completely changed the game. These are not the large, sophisticated drones you might be thinking of. We're talking about agile, fast, and relatively cheap devices, sometimes costing just a few $100s, that can be weaponized to take out heavily armored vehicles. The challenge for any military is how to effectively counter a threat that is both numerous and inexpensive. Firing a $1 million missile at a $500 drone simply isn't a sustainable strategy. This economic imbalance is the core problem Russia, and indeed every modern military, is trying to solve. One of the most visible and immediate solutions has been the addition of what soldiers have nicknamed cope cages. You've probably seen pictures of them: metal sled armor or mesh screens welded onto the tops of tanks and other armored vehicles. The idea is simple: create a physical barrier to either prematurely detonate an incoming drone's warhead or simply stop it from reaching the vehicle's weaker top armor. Initially, these were often improvised, field-made modifications, but we're now seeing more standardized, factory-produced versions, indicating that this is being integrated as a permanent design feature. While they offer a degree of protection, especially against certain types of attacks, they aren't foolproof. Drones can still find gaps, or attackers can use tandem charge warheads designed to defeat this kind of armor. So, while the cages are a start, they're just one layer in a much deeper defensive strategy. This brings us to the world of electronic warfare, or EW. This is where things get really interesting. Instead of physically stopping a drone, electronic warfare systems aim to disrupt it. The most common method is jamming. These systems broadcast powerful radio signals on the same frequencies that drones use to receive commands from their operator and to send back video. Imagine you're trying to listen to your favorite radio station, and someone next to you starts blasting static on the exact same frequency. You wouldn't be able to hear a thing. That's essentially what a jammer does to a drone. It severs the connection to its pilot. Russia has been developing a range of these EW systems. We have smaller, man-portable drone guns like the Stupor, which look like futuristic rifles. A soldier can point it at a drone, and it disrupts the control link, often causing the drone to either hover, land, or return to its launch point. Then there are larger, vehicle-mounted systems like the Pol-21 or the Krasuka-4. These create a much larger defensive bubble, sometimes spanning several kilometers. They're designed to protect convoys, command posts, or critical infrastructure by jamming GPS signals and control links over a wide area. A newer development is the Volaris system, a compact, dome-shaped jammer that can be mounted directly onto a tank or armored vehicle, providing a localized protective shield. The goal is to make the vehicle an electronic black hole for any incoming FPV drone. But jammers have their own limitations. Drone operators are constantly adapting. They can use different frequencies or employ frequency hopping technology that rapidly switches between channels to avoid being jammed. Some drones are even being programmed with basic autonomous capabilities. An operator can point it in the general direction of a target, and the drone uses its own onboard sensors and image recognition to find and attack the target for the final few hundred meters, even if the control link is cut. This constant cat-and-mouse game between jammers and drone operators is a key feature of this electronic battleground. So, if you can't always jam a drone, what's next? You have to physically destroy it. This is where kinetic solutions come in. The classic approach is using anti-aircraft guns. Systems like the Zu-32, a twin-barreled autocannon, are being mounted on trucks and used to create a wall of lead to shoot down drones. But hitting a small, fast-moving target is incredibly difficult. That's why we're seeing the development of more advanced systems. One of the most talked about is the Derivatsia PVO. This is a self-propelled anti-aircraft gun that fires special smart shells. These 57mm rounds can be programmed to explode at a precise distance from the gun, right in front of the drone, creating a cloud of shrapnel. This is far more effective than trying to score a direct hit. It's like using a shotgun instead of a rifle to hit a clay pigeon. It dramatically increases the probability of a kill. This system is designed to be a mobile, dedicated drone hunter, protecting ground troops as they move. Another fascinating development is the use of remote weapon stations equipped with heavy machine guns. These systems, like the Arbalete DM, can be mounted on vehicles and controlled from inside. They use advanced optics, thermal imagers, and target tracking software to automatically lock onto and engage small targets like drones. This takes the human element of trying to aim at a tiny, erratic target out of the equation. The computer can track and lead the target far more effectively than a person, firing short, precise bursts to take it down. It's essentially a robotic guard dog for armored vehicles. But what about even more futuristic solutions? Russia has also been experimenting with directed energy weapons. We're not quite in Star Wars territory yet, but they have showcased systems like the Ratnik BS. This is a mobile complex that uses high-power microwaves to literally fry a drone's internal electronics from a distance. Instead of jamming the signal, it sends a powerful energy pulse that overloads and destroys the sensitive circuits inside the drone, causing it to fall out of the sky. The advantage of such a system is its unlimited magazine. As long as it has power, it can keep firing. It also has a very fast, light-speed engagement time. While the effective range and real-world performance of these systems are still subject to debate and development, they represent a clear direction for future anti-drone technology. So what does this all mean for the future of the battlefield? It means we are in a rapid, relentless cycle of innovation. For every new drone tactic, a new defensive system emerges. For every new defensive system, drone operators and designers devise a new way to circumvent it. We're seeing a shift from relying on a single solution to a multi-layered defense strategy. A modern tank might be protected by a cope cage for close-in physical defense, a vehicle-mounted jammer like the Volnares, to create an electronic shield and be operating under the wider protective umbrella of a system like the Derivatsia PVO or a powerful EW complex. This technological arms race is forcing a complete rethink of military doctrine and equipment design. Armor, firepower, and mobility are still important, but a vehicle's electronic warfare suite and its ability to defend itself against swarms of cheap, intelligent weapons are becoming just as critical for survival. The solo, heavily armored king of the battlefield is now a vulnerable target without its network of layered defenses. This evolution isn't unique to Russia. Every major military power is grappling with these same challenges. The lessons being learned are shaping the tanks, ships, and aircraft of tomorrow. Thank you so much for joining us on this deep dive into Russia's evolving drone defense systems. It's a complex and fast-moving field, and we've only scratched the surface today. What do you think is the most promising anti-drone tech? Let us know in the comments below. If you found this video interesting and want to learn more about the latest in military technology, make sure to hit that like button and subscribe to our channel. Your support helps us create more content just like this. Thanks for watching, and we'll see you in the next one.